Hello, everybody, and welcome to your second week of online learning for CM 391. I hope this video finds you healthy and safe, social distancing, and all that good stuff. But today I want to talk to you about a really important subject, and it's a topic that I don't want you to leave this semester without having had an experience with and learning some stuff about, because it's probably something that you're going to deal with on the majority of the job sites that you go to, and that's excavations. The reason this is so important is because it is so dangerous, and it's something that we deal with on almost every job. And so I want to make sure that you leave this class getting the basics of excavation safety and having some understanding of it. So today, that's what we're going to talk about. And I'm going to go through a PowerPoint presentation, probably in 2 separate videos. And you're going to have an assignment or 2. I haven't really decided yet. Maybe halfway through this video, I might decide. I don't know. But whatever I've assigned to you, it'll be in that week 12 folder, or week 11 folder. I guess that's week 11 folder, so that you know what you need to do. Okay? So I'm going to go through a PowerPoint presentation. We're going to skip over some of the videos. I'll post those videos in the folder for you to watch, but it just doesn't work very well for me to play them during the PowerPoint presentation. So I'll skip over them, and you'll have a chance to go back and watch them, and I encourage you to do that. So let me do a screen share here so that you can see what I'm going to be going through. But like I said, this is a really important topic for y'all to understand. And the reason is because it's really dangerous. Now, I've explained to you in past lectures how heavy soil is. And so soil can weigh anywhere between 110 pounds per cubic foot to 140 pounds per cubic foot. It's a lot, okay? It's a lot of weight. You can imagine that if somebody who weighed 140 pounds was standing on your chest, it would be really difficult to breathe. And we're only talking about a cubic foot of material that weighs that much. Pulling your foot out requires 750 pounds of force. Now, I can't squat that much, and I would not be able to pull my foot out. Pulling your arms out, you would not be able to pull your arms out if they were buried in soil. You're going to be trapped. And like I've told you before, when that soil is on your chest and you breathe in and your chest contracts, that soil contracts with it, and you're not able to breathe out or in anymore because that soil is on your chest. And so you can suffocate with your head above the soil. And that's really a scary thought there. The way that a trench fails is really important to understand, because as a person that's going to be on a job, you can be watching for this. Now, it has it creates what is called fissures, which are just cracks in the soil. And this is when the soil is about to fail, when you start seeing these fissures on top of the trench. Now, you won't see these from inside the trench. If you're in the trench, it's not like you can say, oh, it's about to collapse. No, you're going to see these from on top of the trench, where you probably should be, not down into in the trench. And so it's a wedge that will slide off and will trap you and will pin you between one side of the trench and the soil that's coming in. That's how it fails. This is possibly what a fissure could look like. You just start seeing these little cracks right here. And those are fissures. And so that soil is about to fail. That soil is about to come into that trench. You can also see another problem with this trench. It looks like there's a little bit of water down on the bottom. That's probably why it's about to fail. So that's how it works. Now, this is a video that we're not going to watch. We're going to skip on by. This is another one. I really want you to watch this one. So make sure you go see the Oregon OSHA excavation inspection. This is an actual OSHA inspection on a job. And it's really interesting. The trench actually begins to fail with somebody in it while OSHA is there filming. So not a good situation to be in, obviously. So let's talk about excavations. Now, every excavation needs to be managed by a competent person. Now, you guys know that a competent person is a person who's able to identify hazards and has the authority to eliminate those hazards. That's important. But on a trench, on an excavation or trench, that competent person needs to be able to identify trench hazards specifically and have the authority to eliminate them. So they're going to be able to conduct tests for soil classification, which I'm going to talk to you about how to do that, understand the standards, determine proper protective systems, which we're going to talk about because there's different types that can be used, recognize and reclassify soil after conditions change, because things happen and conditions change, determine whether damage to excavation safety equipment renders it unusable. They need to design structural ramps if those are going to be used for entering and exiting the trench. They need to know all of the underground utilities, which I'm going to talk to you a little bit about. Water removal, if there's water in there, that's a big sign of a dangerous trench, and they need to be able to monitor that. They need to do daily inspections, and actually more often, which I'll talk to you about, and determine the necessity for a protective system if less than 5 feet deep. Now, that's the magic number for needing a protective system, is 5 feet deep. Once it's over 5 feet deep, it needs a protective system if somebody's going to go down into that trench. But even at 4 feet, it could still need a protective system. You know, if you're in 4 feet of beach sand and you have somebody that's working down on their hands and knees on a pipe, and that soil is still a couple feet above their heads, they can be buried and trapped in that. So you would want a protective system. Even though OSHA doesn't require it, there's still a hazard there. Okay, so this picture right here, this competent person's inspecting this trench. You will learn that although this trench looks safe, it probably is not. Okay, you'll see that there are some problems with this trench, and I'm going to show you this picture in a little bit. Now, these guys right here, take a look at them. All 4 of these guys right here. This is not a competent person. He may be standing there, but he is not a competent person. So all 4 of these guys, you can tell that this trench is over 5 feet deep. So that's one problem. It has no protective system, and there's water down on the bottom. There's overhead hazards. So some of these guys, if not all of them, are not wearing hard hats. And so that's an issue because they're down there without hard hats. So they're obviously at exposure, but multiple levels of exposure. Okay, this guy here. So if you'll notice, there's a guy right down here in the trench. There is absolutely no reason for him to be there. He's holding the pipe in place. Why? I don't know. So we've got quite a few problems here. We've got the fact that there's a piece of equipment up here causing vibrations that could cause that trench to collapse. That trench is deeper than 5 feet, and there's no protective system. And then I want you to notice over here, the spoils pile is very close to the edge of the trench. And he might be wearing a hard hat. I can't really tell from this picture, but things from the spoils pile could fall in on top of him, for one. And for another, the spoils pile actually puts a pressure, a surcharge on the soil, which can cause it to collapse. So this guy's in a lot of danger. There's no reason for him to be down there. These folks here, they're obviously being very, very safe, right? We've got a couple of issues. I mean, Now, these guys are in serious danger right here. Let me go through it with you. Usually in class, I'll say, hey, what do you think the problem is here? But let me talk to you about it. First of all, we've got overhanging. This is undermining this road. This road is hanging over the tops of their heads, but they've got hard hats on, so they're all right. There's no protection. We've got live traffic on this road, and there's no protection protecting them if a car decided that they weren't paying attention and they're going to drive off into this trench. We have obviously deeper than 5 feet, so we're going to have trench protection in here, and they have no trench protection. They've got ladders in and out, so they have access and egress. But these guys are in a lot of danger right here. Very easily, they could be injured, killed, buried. Big problem with this trench. Okay, these guys. Now, they're in a lot of danger too, because what they have there is what they think is trench protection. And what I like to point out about this is this can actually create the hazard. They think they're managing the cave-in by putting these pieces of wood, and you can use wood as shoring, but what they have there is not acceptable. And so this is giving them a false sense of security to go down there and do work, and it's actually not going to protect them. So looking at these guys, this guy's smiling for some reason, but he shouldn't be, because he's obviously in a trench that's deeper than 5 feet. It looks very granular. The type of soil looks very granular and could definitely cave in on these guys. So they are at exposure. There are different types of soil. Now, maybe some of you have taken a soils class, but let me tell you, this is all you need to know about soil, at least for safety. This is really important stuff for you to know about soil, and it's fairly simple. We have type A, B, and C soil. A, B, and C. 1, 2, 3. 3 different types, okay? Type A is your hard soil, but it's still soil. We also have stable rock, which is more stable than A, B, and C, but 3 types of soil. Type A is your hard and cohesive soil. It has a compressive strength of greater than 1.5 tons per square foot, TSF. Type B is still cohesive, but it's granular in nature, and it has a compressive strength of greater than 0.5 tons per square foot. So between 0.5 and 1.5, you have type B. Less than 0.5, you have type C, which is granular. That's your really weak stuff. Now, when we're talking about a cohesive soil, type A, we're talking about kind of a fat clay, okay? It doesn't have a whole lot of granular stuff in it. It's just a fat clay that holds together really, really well. Type C, on the other end, is almost like sand. So it can be more than a sand. Like, it can hold together more than a sand, but it is definitely like a beach sand when you think about it, okay? So it's important that we're able to identify which type of soil it is, because there's different regulations that go along with each type of soil. So examples of a cohesive soil would be clay, silty clay, sandy clay, and clay loam. This can be a type A or type B, depending on whether it's granular or not granular. But that is cohesive. So it really holds together. So think of like pottery clay. And that's the cohesive nature of that type of soil. Now, this is a very easy chart to determine what type of soil we have. So the first question you ask is water present? If there's water present, we automatically go to type C, no matter what it looks like. Even if it's a cohesive fat clay, if there's water in there, we treat it like a type C. If there's no water present, we have to ask ourselves, is the soil cohesive or granular? If it's granular, it could be a type A, B, or C. Or I'm sorry, if it's cohesive, it could be a type A, B, or C. If it's granular, it's automatically a type C. Okay, so it's really simple. Most of the time, we are determining that our soil is a type C, and we treat it like a type C. If it's a cohesive soil, and we know it's a cohesive soil, we can go do some tests to find out if it's a type A or B, or it might still be a C. These are the tests. And just so you know, these are in your book. And so some of you may have done a test like this in soils class, but these are the types of tests that you may use on a job site. So next time you're on a job site, walking by an excavation, reach down, pick up some soil from the spoils pile, and see if you can do these tests. They're pretty simple to do. So the first thing we need to do is we need to figure out if it's cohesive or granular. And so we're going to take a look at it. We're going to take a look at the dry strength. So what you're going to do is you're going to pick it up, and if it crumbles in your hand, we're going to determine that it is granular. If it breaks into pieces, but it's really difficult to break those pieces into smaller pieces, it may be cohesive. It may be a cohesive material. So if you think about a dry clay, when you break it, you might be able to break it because it's broken up into pieces. But when you take those smaller pieces and you try to break them apart, it's really difficult to break them apart, and that's hard to do. Okay, so then we've got our thumb penetration test. So if you look down in the right-hand corner of the screen, this is your thumb penetration test. So this is going to tell you what your tons per square foot is. And so you're going to roll the material into a ball, and you're going to press your thumb against it. Now, if you're able to press your thumb all the way through it pretty easily, it's going to be less than that 0.5 tons per square foot. And so it's going to be considered a type C. If you press your thumb against it and it's really hard to indent it, it could be a type A or B. If it's really, really difficult to push your thumb into the material, it's probably greater than 1.5 TSF, which would make it a type A. If you can penetrate a little bit, but it's hard to go much further, kind of like this guy is doing right here, it's probably between 0.5 and 1.5 somewhere. Okay. The other one, the plasticity test, this is another way to tell if it's granular or cohesive. So you're going to put some moisture into the soil, and you're going to try to roll it out into a 1/8 inch thick little worm on your hand. So you're going to roll it out. And if you can get it to 1/8 inch without it breaking into smaller parts, kind of like this guy has done, if you can get it to the length of your hand, it's a cohesive material. If it starts breaking into smaller chunks before you get to that 1/8 inch thick, it's granular. Okay? So these are tests you can do right there in the field just by grabbing a chunk of soil from the ground. Okay. This is going to be one of your assignments. So this is going to be the competent person interview statement assignment. You know what? I'm gonna come back to this. Okay, we're gonna come back to this at the end, and I think I'm going to go to the next video now, and we'll start talking about the other pieces. Now that you know what a type A, B, and C soil is, we'll talk about the other pieces of it and what you do now that you know that it's a type A, B, or C based on the test that you've done.